Hey everybody, welcome to Data Engineers Lunch number, sorry, it should not say 8, it should say 6. No, we haven't done it for that long. Welcome to Data Engineers Lunch number 6. Today we are going to be covering common data formats, specifically for, that are used in data engineering. If you're new to data engineering, you may be working with some CSV files, you may be working with some XML files, TSV, or maybe it's just unstructured text. But what we're going to do today is we're going to cover the most common data formats and why you would use them for whatever reason. And love to hear your thoughts about if there are other better data formats to use for data interchange. Thanks, Akwi, for getting us started today and being the co-organizer, getting the content out there on YouTube after we've done this, and getting blog posts out there as well. I'd love to have some people help out. Co-organizer, really what we need is somebody who can get speakers or can help produce events. Right now they're all virtual, so they're pretty easy. We're part of Data Community DC. We believe in diverse communities with people from various backgrounds, race, gender, sexual orientation, religion. If you know somebody who's underrepresented in the tech community, the data community, that is an appropriate topic leader and can talk about something around data engineering, love to have them. We are part of a group of meetups in the DC, Maryland, Virginia metropolitan area. So DC doesn't mean DC. We have folks in Northern Virginia as well. A lot of folks would come to DC for work, and they stay for the meetup, and then they go back home. This meetup, Data Engineers Lunch, is actually part of Data Wranglers DC, where we cover stuff around moving, processing, cleaning, scrubbing data for the purpose of either visualization, exploration, machine learning, data science, you name it. You got to get data to clean it before you can do stuff with it. Let's see if there are any new faces. I was commenting about this earlier. I just don't understand who designs the UI feature. It's not great UI. It's saying that I have some audio issues. Can you guys hear me okay?
We can hear you now. You were turning into a robot for a second.
All right, I'm just gonna call in so that we don't have that issue. 1 second.
You sound very good now.
Hey, everybody, can you guys hear me?
Yes.
A little bit better than before. Great, sorry about that. I should always do that. I should always call in. But I think I was doing that for a long time and then forgot how bad whichever IP gets. I don't think we have any new faces, so we can skip the intros. Group rules, if you have a question, just ask it. Be polite, share stuff that you know. We are one of the sponsors here at Anant. We focus on Cassandra data platforms with Spark and Kafka. DataStax is a partner and a sponsor. So is the Masters in Business Analytics at George Washington University. Data Wranglers has sponsors in the DC area as well as in Chicago, where we've done a couple of these. And we have organizational sponsors who support the whole organization, Data Community DC, which is a nonprofit foundation, which means their advertising dollars can be tax deductible because they get to put their name out and support a worthy cause. Let's see. Any announcements from the group? Looks like, Will, you had something here related to Airflow. Do you want to talk about it real quick?
Sure. Since in the last couple of weeks, Airflow 2.0 came out, which has a number of improvements over Airflow 1.0, which is what I presented on. And there, the big change is that the scheduler is now truly distributed. It's not just highly scalable, but it's really distributed, which means that it can be scaled even further. And then there are also a lot of quality of life changes around the API, making it easier to author workflows through the API, and a number of UI and other improvements. So pretty exciting, and gotta find someone
Very
to
cool.
give an update on that.
Yeah, that'd be great. It looks like they basically started making sure you need to have a good database so they can distribute the work or keep, the statuses of all the work. And then the scheduler talks to it. Neat. Very cool. Yeah, that'd be great to have an update on actually trying this out. Does that work with Kubernetes and Docker as well, or is right now? Oh, great. Very cool.
And so awesome. the whole thing can be scaled up on a Kubernetes cluster as far as you want.
That's awesome. Very cool. Yeah, fascinating technology. I think it's definitely a good tool to have in your toolkit. And the cool thing I think about Airflow is because it's open source first of all, but it's like system agnostic in terms of the task that's happening doesn't matter what task is happening on which database. This is just coordinating the tasks for you. So very cool. And let's see, we have a couple of thanks for that update. Appreciate that. We have a couple of data engineering related talks coming up. There's DataStax, Astra, and Databricks, which are Spark as a service on the cloud, and Astra is Cassandra as a service. So I should really just. And by the way, I think it's going to be using Databricks community and the DataStax Astra free version, so anybody can follow along, using Databricks. I think both of those are. I know Astra has a free tier, and I believe Databricks community is a free tier where you get to play around with Python and Scala on their notebook environment. It's really nice. Okay, and with that, let's go ahead and get started with today's topic. So we're just going to review the next topic in data engineering, which people always question, which is, okay, so great, we have databases. How do we get data into it, right? And basically getting data into the databases is the first step of the job in data engineering, is to kind of clean it up and structure it. So sometimes we get data in various formats, and essentially we have to process it, clean it, and then eventually get into a database or to get it into some sort of structured system that makes it easy for visualization or for running analytics on top of it. We talked about this in one of the previous previous lunches. Basically, there's all these different tools you can use. You can shell tools, you can use command line tools to do data processing. There's various ETL frameworks for things that are serverless, things that are based on .NET. But ultimately, what is it that you're doing? Well, you're dealing with files. Initially, it may be coming from a database. You store it into a file, you do stuff with it, and you put it back into a database. Or you may be just getting files, and you may be going deeper into that. So the most common data formats that I've had experience dealing with, and by the way, these are just the file formats. There's even domain-specific file formats under each of these that may or may not be aware of, because it's just maybe in e-commerce there's one type of format, or in science there's another type of format. And this is not the exhaustive list. This is just a starting point to dig deeper into. When I started off in just data in general. Essentially, CSV or TSV was and it still is very, very common. And what a CSV format or TSV format is it's basically comma separated, okay, value file, right, the text file, and it's great because you can open it in a notepad, right? You can open it in VI or Notepad or whatever, Sublime Text, and you can just look at it. You can see it. Commonly, what it'll have is it'll have fields or field names at the top. Again, comma separated. So like, you have first name, last name, et cetera. You'll have first name, comma, last name, comma, et cetera. And that is the only metadata that exists there. Right? That's basically, as simple as that. Now, there are some CSV formats where, for example, if you are exporting from, I'll just use Cassandra for a second. So Cassandra, if you have a nested object, it will convert that to JSON. And so one of the fields will be JSON. The CSV doesn't necessarily mean it's always text. You can have text, 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 JSON, and the JSON is all in one line, and comma, text, 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 right? So it's just a way to structure everything in one line. That's really what every major record is. Yeah, I agree. I'm going to kind of copy and paste that. What Will just commented here. It said mediocre data format for software, right? But it's great for moving data, right? That's really what it is. It's not, you don't want to store data in CSV. It's just, if you go to use any software as a service, if they have an export feature, it's probably export as CSV. Because the other cool part about this is that you can open it in Excel, Google Spreadsheets, in an editor, in a tabular editor, right?
I'm just gonna chime in and say that if you give someone data and they can't open the format, for non-technical users, they'll think it's corrupted. If it won't open in Excel, it's corrupted.
Yeah, and again, this is the reason why, because Excel and Google Spreadsheets, by the way, is popular, but people run their whole companies in Excel. It is the most common format because people can just double click on it and open it up in Excel. So great format for moving information around, not that great beyond that. It's also can, when it becomes very, very big, it becomes unwieldy. And you really have to eventually start sharding it and to have different files for the CSV files. Now, TSV pretty much ditto everything about CSV. And actually, you can open up TSV in Excel and all these systems. I think Excel definitely, if you have a .tsv file, it even shows you that it's a .tsv file and you can open it. But the only change is that it's tab separated. And it's again, it's a text file. There may or may not be field names at the top. You can definitely open it up in all the text editors. And then same thing, every major record is one line, right? I could probably say the same thing here. Tab separated, why do people use it? Well, it was one of the mainframes. When you look at information, it was just like text, and one of the best ways to get data out of it was a tab separated value that you could read. And when it's tab separated, it's like one column has, for example, 10 columns. One field has 10 columns. The next field will have 10 columns. So when you're looking at it, it looks like a table. It is easier to read if you're looking at a tab separated value file than it is to read a CSV file, because CSV file, if the first value in one of the rows is 3 characters and has a comma after it, it'll have a comma after the 3rd character. The next one could have a comma after the 15th character. And so if you can imagine like thousands of rows, you can't really open a CSV file and like scan through it and see what the data is. You can do that in a TSV file.
And it was one of the original report formats. Before computer graphics, when people were doing data, like the tab separated value was the report. It was exactly what people wanted to read and look at it. So because it looks like a spreadsheet, right? So tab separated is useful because you can look at it. Humans can read it, and scan it, read it like a report, basically. And I don't know. I have not used a TSV file in a while, but every now and then it'll come up in conversation that a legacy system is spitting out a TSV file. It needs to be processed and put into a more modern database, for example. Now, if you're doing data engineering and you don't know these, get on top of it. And the benefit of like knowing this is that you don't have to learn how to parse it by hand, like in C++ or Python. There are lots of libraries today in all of the programming languages that we talked about, where you can just say import this CSV and it'll make basically like a data frame, or it'll make an array, a two-dimensional array of all the data. And some of them, when you import it, you can even say, like in a data frame, you can say, I want this column, this named column, right? And I want this row. And you'll get it, or I want this row and I want this column, and you'll get the data as if you were in Excel, right? Because in Excel, you can say, I want column number B, row number 15. You can access that data in these programming environments. So that's why it's useful to know, not just because everybody uses it. It's just it's pretty easy to read it and to manipulate it and do stuff with it. Now, JSON is yeah. Can you expand on that? Will, you said TSV is faster for parsing operations.
Yeah. So one of the limitations of TSV is that your text cannot contain tabs, or I believe in most cases new line escapes. So it has to just be a single string, which means you can't actually encode everything into TSV correctly, because no tabs, no new lines. But because you don't have to escape characters, you don't have to spend, your parser doesn't have to spend CPU processing those and looking at each character and saying, is this slash, is this an escaped character? So in some cases, that can actually result in improvement, processing improvements, but usually that's negligible.
Gotcha. Very cool. No, thanks. I appreciate that. That is. It would basically be like common sense, right? You don't have any formatting to deal with, so it's just faster. And if you've like been in a computer science class, like one of the projects you do is like you read a file. Like if you know generally, when the data is going to come up, you know where to like cut it. You don't have to look for anything. You just say cut it, and I want to get that. Right? Awesome. Yeah, and actually TSV works really well with like things like SAT and awk and whatnot, because it's already ready to go for that. It's ready for cutting. So JSON is, I wouldn't say it's new, but it just took over. Actually, before JSON, XML was the more popular system. And actually, let me talk about XML real quick, because JSON is kind of one of the more popular formats now. XML became popular when people started making web services. And what I mean by web services, it's SOAP, which is like Simple Object Access Protocol. But it was even more, it was popular in systems before this as SGML. And HTML, by the way, is written in SGML. So history of XML, most people don't know this, but like essentially everything we do with the web, the HTML format, it's now XHTML. It is XML, right? So people do use it. It's not old. It's just people used to move data with XML instead of something like JSON. And I would say like you can have a whole kind of debate over whether XML or JSON is better. But one of the tenets of XML is that it's self-describing, right? You basically have these tags, right? And you have a tag like this, but you can have like book, right? And you can have author, and you can even have attributes. You can say name is equal to the whole thing, or you know, and then the title of the book is, and this is not a really great format, but like, you know, let's say enterprise consciousness, and then let's see, and then that's one record, right? And I can say this is the book record. And then you can have another one, let's say, and, you know, you can, the benefit of this is that you can, so William has a book, right? William, what's your book called?
Virtual Power, the Future of Energy Flexibility.
Okay, and there's a thing, there's a record for Will's book, and then you can add other things in here. So you can have like ISBN number, right? And I'm just writing it out, but like you may even have a different structure, right? You could have a different structure that's more like authors, right? And you can have author name, and then you can have another author. And so you can see how people like this format, because you would get your data like this, and you would query it in different ways. But essentially what you could do with this is use something called XSLT to reformat the data. So you would say, anytime you see book, use this XSLT subfunction and make it into one row. You can do that, or you could say, use this. There's also something called XSLT formatting objects, but you could take this, you can make a PDF out of it. So there's a whole ecosystem of creating XML, processing XML, but it was a great interchange format. It still is a great interchange format. People still use it in the form of, again, SOAP, or they use XML RPC, remote procedure call. But the benefits, I think, I don't know necessarily if they outweigh the cons. It's very heavy, right? It stores a lot of data. It's repeating all of this information every single time, right? And that's why people started to move towards JSON. And then there's a whole discussion about why we still need XML in some cases and why we probably should use JSON in other cases. But what I like about XML is that you can look at it, you have all the information there. You have all the schema there. The other thing is that you have hierarchy that you don't necessarily get in CSV. You have to use other formatting to store the hierarchy in a CSV, like I mentioned earlier. You have to put, you know, JSON in the actual one line. Hierarchy, but it's heavy, but people still use it. There's a lot of data in XML. Luckily, there are also lots of libraries to you know, take XML and make it into the format that you want. So you can take XML and you can convert to JSON, for example, and that may be more useful to you because you're in JavaScript world, or but at the end of the day, like if you're going to read XML data in a programming language, you're really just talking about objects at that point. If you have XML data and you parse it into an object tree, like you can access that data, right? You can say, go to, just like in JSON, you could say, go to this book, right? And then go to the authors, and then go to the first author, and then get the name. Like you can access that data. And it's not that different than, let's say, if you were using JSON, okay? I don't necessarily have anything against XML. I think it's fine. I love it because it's got everything there. Now, JSON recently has like made a run for it in the last like 10, 15 years. Why? Because all of the web quote services, right? Web services that we were talking about earlier, now are all in REST, representational state transfer. And REST doesn't necessarily mean JSON. It just people use REST with JSON. And when you add data, when you retrieve data, you get it as basically, hierarchical JavaScript object notation. JSON is similar to XML in that you can be hierarchical. Right? You can have a hierarchy in there. It's readable, right? Human readable, just like XML. And you can have metadata in JSON, but it's not as heavy, right? So like the same exact thing, let's say self-describing here, we would have like book, and I believe I would say books is an array, and then you can have book, right? And then you can say like this, you can say book is actually a collection of, let's say, author, and then I want to put one here, author, and then this is, I'll just put like below here, okay? And then you can have another book, similarly, and if you have schema in here, you can just see compared to JSON compared to XML how much less characters it uses to store the same information, and that's really what JSON is doing. It's getting rid of a lot of this end bracket stuff. It's getting get rid of all these stupid open and close tags, and it just stores raw data. That's what it is. It just stores raw data, and you don't necessarily even need to have this here, right? You can just assume that this is a collection of books, right? And you have all of your anything in that array is a book. You can just assume that, and so it just takes less data altogether. And I think the other thing we have to put here is a title, right? But now this is not something that's going to basically pass the parse test, but it'll just show you, it'll illustrate to you like what we're talking about here. And so because both of them support hierarchy, you can do things like XML to JSON, and there's functions and there's compiled code that can do this as well. And it'll approximate what you're looking for. You may still have to do further processing, but it'll at least bring it down to the JSON format. So, sorry, I put this in the wrong node here. There are new formats now with JSON that also have stronger schema management. And actually in XML, there's a system called XSD, XML schema definition, which you can verify an XML file against. So similarly in JSON, there's an Avro schema specification that you can write. And you can make your own too, but this is a common one, where in Avro, you say, like, this is the structure of my data, and, in order for it to be this data, it has to pass through this Avro spec. And, we use Avro in Spark, we use it in Kafka, you can use Avro anywhere. The reason you would use Avro is you're basically getting the benefits of XML, right? The schema management and structure and strong typing, and you're getting it in JSON. That's why Avro is great. It gives you what benefits we got from XML in JSON. And I don't know, I mean, this is kind of the world of data these days. If you're working in basic data management, and I'm talking about like you're doing things like import, export, and you eventually put it into a database and you start using it. This is kind of what you're working with. Then in the world of big data, what ends up happening is there's a ton of data, tons and tons of data, and you get them in terabytes and petabytes and gigabytes. And so what we have to do is eventually really deal with compressed formats of the same data. So, and I'm not that familiar with binary compressed data except for Parquet, which is a columnar storage of data that is stored in files. And then you can pull it up as a database. and the other is BSON, which is basically binary JSON. And actually, Arrow data can be compressed as well, because there's a structure to it. When you uncompress it, you know it's going to be good. And of course, you can take any of this stuff and you can compress it in a tar-gz. And there are, you know, in the data engineering world, you can pass zip files around, you know, or tar-gz, or zip, what is it, 7z is another format. But basically, you can pass these around, and your programming client essentially can be told to just read the data directly from the compressed files. And it will uncompress it on the fly for you. It'll get the data, and then when you're done with it, you want to save it back, it'll do that thing for you. So it's not like there's anything special about this. It just takes up less space. And that's why people do it. They'll just tar up everything and send it over. In data lakes, commonly when you're storing data or retrieving it, let's say like a Parquet, you can set compression parameters to say store this data compressed or store this data uncompressed. And what it's doing is it's using less or more space, but there is a pro and con with that. If you have it uncompressed, it'll load up faster. If it's compressed, it'll take a little bit longer to load up. But once it's in whatever system, it's in memory. Any other formats for pure data? I was thinking about just generally files like PDF and doc and all that, but I mean, they're not really data. I mean, those are more like documents that you're kind of looking into and figuring out how to parse it. Trying to think if there are any other data formats. Anybody else, you know, encountered anything else different? Pretty much this is it, I think. Yeah, I think this is it. If it's something different, what it may be is it's a variation. It's a way to do this. So, for example, in JSON there may be something called geoson, or in XML you may have what's called EBXML. Yeah, electronic business XML. You know, basically it's a way to do interactions between organizations that was related to e-commerce, for example. So, and there are, and you can do this on your own, but there are various formats. I remember back in like 2001, there was an infographic for the different file formats, and it was already big. So like now, 19 years later, I can't imagine. No, this is not. I want to show like for dramatic effect. There we go. Here. Oh yeah, this looks kind of like what I'm looking for, but it's like the lineage of XML data, and unfortunately, it's gonna make me kind of like sign up and do stuff. Oh, I can't even look at it. But here we go. SGML became XML, and then from here is probably HTML should be somewhere. XPath. Oh yeah, and this is just the schema languages for XML. This is not even the different types of XML that's out there. This is just the schema languages. Let me see if there's something. Usually Google like has it on top of it. Okay, here's one in, I guess, maybe the world of just science, but and this actually has like different things. So for example, XML, probably XML, but there may be these other data formats. Like if you're in the scientific world, you have these other data formats. I'm not familiar with these. Maybe it's a text format. Maybe it's a binary format. I have no idea. But it's not like you're gonna know these data formats and that's the end all be all. Like you're always gonna come up against a different format. Most of the time you're gonna end up with these. That's what my prediction is. It's going to be one of these. It's like there's only so much you can do with information when it's sitting at rest, basically. Awesome. Well, that's the kind of end of my topic discussion for today. I just wanted to get everybody exposed and get everybody on the same page. Anyone have questions or wanted to add to this conversation?
Yeah, I think on the topic of binary data, if I recall correctly, Avro also has compression to binary, and if I understand correctly, that actually can be one of the most compressed and efficient storage formats, because it can shape based on how it does the sort of definition separately from the data itself. It can shave a byte or two off each entity, which at scale really adds up. I think I mentioned it, but thanks for reiterating that. That's why it's become popular, is because it's best of all worlds. You got your schema, you got your validation, it's JSON, and it's fast compressed, definitely. I mean, there have been I'm just trying to think. There's been different ways that we've had to do interchange between systems, and always ends up being like some variation of this. I mean, XML itself is just like the world. The whole world is still moving with XML. And you know what? Let's do a Google Trends analysis, because this will truly tell us, what are people looking for? So CSV, separated values, file format. Okay, cool. You know that it'll be more accurate that way. TSV. Okay, well, it's not one of those. Hold on. Tab separated. Okay, good. Found that. XML format. Well, they call it application interface. Hey, look at that. XML's not doing too shabby. Still there. JSON. I think it's going to crush it. There we go. There's JSON. And then compared to Avro, I think, which is, again, it is JSON. Okay. Avro is, it's kind of new. It's new. But let's look at the history. The world began for Google 16 years ago. So I'm curious. So there we go. There's XML, right? And it's kind of gone down. But then JSON, JSON has definitely taken over. CSV, as you can see, it's remained basically the same. It's fairly stable. Let me get rid of these so it's not skewing it. Yeah, look at that. Still. So, I mean, it's relative, right? So, like, people still use XML. People still use CSV. JSON has just become a very popular format. I wonder if Parquet is anywhere. Well, people may still be looking for Parquet for patterns, but I think Parquet is a fairly new system of data storage. Interesting. So if you're going to be doing data, get to know these. They're not going anywhere. And I didn't mention it, but I don't think it's a data format, but people will also do SQL dumps of data, or they'll create insert statements. I mean, I don't think that that's data format. That's really, you're producing SQL commands
where the data is in there. I don't know. What is your thought on that, Will? I'm curious what you think about this. Yeah.
So that's actually the first I've heard of that, and I think it's an incredibly clever interchange format, because there you can just take the text and put it immediately into a new database.
Yeah, I mean, I've actually done some rigging where we got CSV. I opened it up in Excel, and I constructed it using the concat statements, and we're able to save that as a SQL and then insert it. Because it was quicker than to write a program to do it with the special, formatting. When I say quicker, like you can put together that thing in Excel in like 5 minutes, where it says, oh, I got to write a little program to do this. So yeah, in a bind, it was very useful. So
I've also done,
yeah, go ahead.
I've also done some things with concat, basically concatenating programming commands using Excel. I've done some things that I'm both very pleased by and not proud of.
Oh yeah. Yeah, absolutely. Like if you have a list of IP addresses and you need to run an SSH command on it, I mean, just go to Excel. If you don't want to get to know Bash intimately with like, for each, like that works perfectly fine. Yeah, that's a topic, how to use Excel to like make it. Actually, that might be a fun little tip and trick session. Using I was going to ask, Pramod, you've done databases for a long time. What's another common data interchange format? There may not be one. I'm just asking if I'm curious if you know of anything else that we're not covering here.
SQL, I can say.
What is that?
SQL.
SQL. Oh yeah. That's what we're saying. Like you can save the data as SQL and insert it. Awesome. Well, all right. Well, I think we had a pretty good discussion about data formats. This will get published out there. Yeah, go ahead.
Yeah, I was going to elaborate on actually a comment you made earlier about language-specific encoding formats. One of the ones that I run into a lot is the pickle binary file for Python, which is Python's basically like unique / custom file format. You can very easily convert an object or data in Python into a binary file and save that to disk. And there, a lot of other languages have similar binary file formats, most of which, because they're so accessible, are fairly good to use. I don't know about other languages per se, but I know for Python, the real challenge there is pickle files you can't always open them with non-Python software. So they can be challenging to open in other programs. The other interesting thing that I'm going to use that as a segue for is, when it comes to compression, compressing binary files, there's actually a huge trade-off between speed and compression size. You can usually compress a file more at the cost of putting more CPU into it, which in most cases it's not really a trade-off worth thinking about. But once you start getting up to actually big data or trying to make things efficient, you start having some real trade-offs there.
Yeah, and actually you brought up a good thought for me is that in general there's serialization, deserialization formats, right? In any programming language. And this point, what we're talking about is well, I can't really make that correction. What we're talking about is that when you are in a programming environment, your programming environment it may have a way to take your object that you're working with and to store it in a data at rest format, basically. And in some environments, it's actually XML. You can serialize an object into XML. You can deserialize out of it XML. And what's another way is to do it in a binary format, like we'll just mention. But the benefit of that in any environment, like in an API environment, for example, if you're doing massive operations on objects and you need to expose them to another system, you could save it in a cache and then have an API that then gives you access to that object, and then you pull that object back and you deserialize it. But it has a state of that whole object in there. And an object can be very complex. An object can have threads, it can have variables, it can have, threads may not necessarily be serializable, but that's a different conversation. But at the end of the day, it's about having a state of a running system saved into something that you can move and then access it elsewhere. If you look into Spark, there's a way to change the way you move objects in Spark. It's called Cryo. It's a much more, it's a faster way to move data between Spark nodes than the out-of-the-box Java-based one. So I hadn't thought about that as a way to like move data, but that's actually makes sense, because if you're going to be picking it up with the same exact programming environment down the line, then it doesn't really matter how you, as long as you use the same exact system. Now, there are, so JSON is probably the de facto serialization format that people use without thinking about it, because when we use APIs, what we're really doing is we're getting a state of an object. We're getting a deserialized version of that data. And then when we manipulate it and save it, it's serializing it. It's probably putting it in its own way. It doesn't necessarily have to put it in a binary format, but when you do API programming, you're working with serialization, deserialization all the time. You're just not knowing that you are. Let me see, common or interchangeable serialization data formats. That's a really interesting subtopic of this. Here we go. Wikipedia has its own page on this. Must be serious. Look at that. So, hey, we talked about Avro, we talked about Parquet, Bson, CSV. Here, this is good. I'm going to copy this and put this in the workflow. Let's see, JSON, PHP serialization format, Pickle, Protobuf. This is a relatively fast one. It allows you to move data very, very quickly between systems. XML RPC. Oh, wait, we didn't even talk about YAML. I don't know. I never thought of YAML as a data interchange format, though. It's it'll be too long.
And isn't it just, well, I guess not. I assumed it was just used for configuration files.
I mean, you can serialize something into YAML and deserialize it, right? It's just like JSON in that respect. People use JSON. And here's, let's see. This is a good article. I think I've seen this before, but I'm going to put this in the workflow, and I'll put it in the chat. Here we go. But this kind of, sorry about the metadata there. OPML, there's another data. That's another XML format. There we go. So it kind of talks about JSON, Bson, I don't know what message pack is, YAML. This is new. Hierarchical data format. You know about this? You're muted if you're speaking.
Oh, yeah, I've heard of HDF5, but know very little about it.
It's taking the data science and other industries by storm, apparently. We're not part of the storm. Okay. Well, it's good to know that there's at least another format for big data other than Parquet. Yeah, this is new. This is new for me. There's a format that is called Apache Arrow, language independent, but it's for storing data in memory. And yeah, it's kind of like becoming the common way to move information between systems very quickly, right? It's just an in-memory representation of the data, so worth looking into. I don't know if I would be going into this in my work. If you're making software that does a lot of data, that you're building software that does data stuff internally, that would be one thing to look into here as well. All right. Pramod just sent something, text file. Oh yeah. Well, yeah, actually, funny you brought up like how many different text formats there are. not just the ones that we talked about. Oh yeah, log files are text files. So yeah, good stuff. I'll put this in there as well. Different ways, various different ways of having data stored as text. Cool. All right, folks, we're at the top of the hour. Apologize for starting a little bit late. We'll get, what is that? What did you say, Will? Database. Yeah, definitely. I was thinking that is the next logical topic because we're kind of going down this thing, right, from programming, scripting, and I think the data format was the next logical one, and then going into each of these one by one. So like there are so many different relational databases that we can, well, so many that matter. MySQL, Postgres, various variants of MySQL, Postgres, and then the NoSQL world is massive as well. So what particularly did you want to know about Postgres?
Nothing in particular, though I spent far too much time this weekend fighting with Postgres configuration around, especially a lot of the networking and authorization.
Yeah, best thing I can say is that about databases, I mean, I used to run a hosting company. We used to run databases with like multiple users, multiple databases, and you know, it was like MySQL, SQL Server, and then Postgres started to become popular. And by the time I kind of left it, you know, it was those three. And, you know, it's now with like the ability to just go to Amazon and say, I want a database, and then they just manage it for you. I look back at the days of, it's the same thing as, you know, having to build a server. It's like, you just push a button, you get a database. So, and, you know, especially with Postgres and MySQL, there are scalable data stores like MariaDB Galera, and Postgres has variants like, I think it's called like, it'll come to me, but it's like something Midas. There's a way that Postgres can become clustered and continue to grow, but then there are scalable databases that provide a Postgres compliant interchange, although under the hood they're kind of different. Like I think Greenplum is one, and then there is CockroachDB is Postgres compliant, for example. So yeah, let's do that. Next one we'll do databases. Part one of like databases.
Maybe this Aurora Postgres or like RDS Postgres is good enough. Like they have like their own schema conversion tools. Like if you want to migrate from Oracle to Aurora Postgres, like we can do it easily. The only thing that we need to take care is like just the schema. like they have some different formats, like date formats. So we just need to make sure like those formats were changed, and then like it's easy to migrate.
Yeah, I mean, Postgres just, and this is the last thought because we got to hop off, but Postgres is becoming the de facto database for people getting out of Oracle. It's basically got all of the benefits that Oracle has, but there's not a license cost to it. And Postgres can store data as XML and as JSON, and allow you to query data as JSON and as XML. It's like a really awesome database. So.
And this
awesome.
new SQL also, like new SQL, like the Cockroach DB, like it is a kind of competitor for like Postgres, I can say.
Yeah, definitely. Gigabyte also has a Postgres compliant layer to it. So, I mean, if anything, Postgres itself. And if you guys look into the history, like Ingress was the first kind of one of the first relational databases. And every major database is modeled after how Ingress worked. And now Postgres, people are kind of finding its roots, but the people that made Ingress, Postgres, like they were the leaders in relational database technology. They were the pioneers of this technology. And, if people think that MySQL is more popular, well, there's no reason for people to necessarily use MySQL over Postgres. Like, it's just, I think Postgres is the better database, but I think maybe MySQL is easier to get started with, right? Just press a button and you get up running. So, all right, folks. Sorry to keep you late. Have a wonderful holiday if you're celebrating. There's a lot of, like my wife is Persian, so it's like Yalda, and maybe there's Hanukkah, so there's all these holidays. Happy holidays. And next week won't be quite next year, I don't think. So we'll see you on the 28th. See you later, guys. Take care. Bye-bye.